That morning, the 23rd of January 2026, Yellowstone looked as usual. A soft vapor still rose from the ground, creating a thin mist that blended with the cold air. Snow covered the wide valleys, and the sounds of nature, wind, birds, and hot springs filled the silence. Visitors walked the boardwalk, capturing the scenery that had long been a symbol of nature's beautiful and serene power. There were no warning signs, no strange sounds, no hint of disaster. But Yellowstone is more than just a national park. Beneath its layers lies a vast volcanic system that has been the focus of scientific study for decades. Researchers monitor every tiny tremor, every temperature change, every shift in the ground, because they understand one thing: the Earth doesn't always speak loudly. Sometimes it signals through subtle changes, and sometimes it changes in a flash. That day, those signs came in an unexpected way. At 8:17 a.m. local time, the ground in Yellowstone suddenly shook violently. The tremors were no ordinary tremors. Within seconds, seismographs registered a magnitude 7.9 earthquake, a rare occurrence in the region. Earthquake waves spread in all directions, penetrating valleys, striking rocks, and shaking the surface like giant waves. Trees swayed, the ground creaked, and walking paths cracked. Park facilities suffered structural damage, and several landslides occurred on slopes. Visitors were startled, some fell, and park officials immediately activated evacuation procedures. Meanwhile, the Earthquake Monitoring Center worked non-stop. Data was transmitted to laboratories and geological institutions around the world. Within minutes, Yellowstone was at the center of global attention, not because of speculation, but because of the fact a major earthquake had occurred in the heart of one of the planet's most important geological systems. Hours after the quake, more visible effects began to emerge. In several locations, large cracks appeared in the ground, some as wide as 38 feet, the size of a four-lane highway. These cracks not only extend, but also penetrate layers of soil that have previously appeared stable. Warm steam is escaping from these cracks, accompanied by a distinctive sulfurous odor. This is a sign that subsurface activity is changing. Geologically, these cracks are the result of a release of stress in the Earth's crust. A large earthquake forces rocks that have been held under pressure to shift. As a result, the ground surface ruptures, forming fissures that can stretch hundreds of meters. For scientists, these cracks provide a preliminary map for understanding how stress moves within the Yellowstone system. While the cracks reveal changes at the surface, data from underground reveals bigger changes. High-precision GPS measurements and satellite imagery indicate that several areas of Yellowstone are experiencing unusually large-scale ground uplift. The ground has risen several centimeters in a short time, a change that rarely occurs over such a short period in volcanic systems. This phenomenon indicates pressure from below the surface, usually related to magma movement or changes in the volume of hot fluids within the system. The rising magma increases pressure on the overlying rock layers, pushing the ground upward like an inflating balloon. Seismic sensors record characteristic vibration patterns associated with the movement of hot fluids. Gravity measurements also indicate changes in the distribution of mass underground. Scientists emphasize that uplift is not direct evidence of an imminent eruption. However, it is an important signal that Yellowstone's volcanic system is geodynamically active and requires intensive monitoring. That same afternoon, Yellowstone demonstrated a dramatic response from its hydrothermal system. Steamboat Geyser, known as the world's tallest geyser, suddenly erupted with enormous force. Hot water and steam shot tens of meters into the air, forming a column that resembled a giant steam column. A rumbling sound accompanied the eruption, and small tremors were still felt in the surrounding area. Witnesses described the moment as a sudden change in the normally stable landscape. Some visitors recorded videos, while park officials warned against approaching. Scientifically, this geyser eruption is related to changes in underground pressure. Earthquakes and magma movements alter the balance of hydrothermal systems, networks of hot water and steam flowing beneath the surface. When pressure changes rapidly, water stored in underground channels boils and vaporizes, then erupts. Massive earthquakes, giant fissures, uplifts, and geyser eruptions are not isolated events. They are all connected within a single, vast system, the Yellowstone supervolcano. Earthquakes change the structure of the crust, opening new pathways or widening old ones. The fissures allow hot fluids and gases to move more freely. The rising magma changes internal pressure, triggering uplift. The hydrothermal system responds to these pressure changes by erupting geysers. In simple terms, Yellowstone functions like a massive engine, transferring energy from within the Earth to the surface through various pathways: rocks, magma, hot water, and steam. Scientists emphasize that Yellowstone is not a system ready to explode at any moment. Supervolcanoes operate on very long timescales. Extreme activity can occur without triggering a major eruption. But this event demonstrates that the system is highly sensitive to changes in pressure and energy, and when those changes occur, the impacts can be quickly seen on the surface. Yellowstone is now a focus of global monitoring. Scientists from multiple institutions are working simultaneously. Data from seismographs, satellites, thermal drones, and gas chemistry sensors were rapidly processed. Computer models were updated to predict magma movement patterns, pressure distribution, and the likelihood of further changes. The scientific discussion was intense. Some experts argued that this was an extreme geological phenomenon that was still within the normal limits of the Yellowstone system. Others emphasized that these changes indicated a new phase of activity that needed to be better understood. But one thing was agreed upon. This event was a reminder that the Earth is always in motion, and a large geological system like Yellowstone cannot be understood superficially. The world now awaits the next data, not to instill fear, but to increase understanding and preparedness. Because in Earth science, the most important thing is not knowing exactly what will happen, but understanding the mechanisms at work and ensuring that humans are always positioned to respond appropriately. Yellowstone didn't explode that day, but it spoke through quakes, fissures, and steam, reminding us that the Earth is a living system, one that is constantly in motion, even if we don't always see it.